In this lesson, we're looking at the properties of linear functions. And so when we talk about them in equation form, a linear function is a relationship between two variables where both variables are raised to the first power. And we should also mention that those variables cannot be multiplying each other. They can be connected by addition or subtraction, they can be on opposite sides of the equation, but they cannot be multiplying each other. So first power, not multiplying each other. Now, there are three primary forms that we'll see a linear function written in. One is called general form. It is functionally the least useful in terms of being able to just look at the equation and determine features about the line and what its graph looks like. And then we have two that are a little bit more useful. There's slope-intercept form, which I'm sure we're all familiar with, y equals mx plus b. And then there's one that's quite similar, but uses a point somewhere else on the line instead of the place where the graph crosses through the y-axis, and that's a point-slope form. So we still see the slope in that equation, hence the word slope being in the name, but now instead of the intercept, the y-intercept being the information about the point that we have, the line that we have, instead we have some random point along the graph of the line, x1, y1. But we'll talk about that a little bit later. So first things first, looking at the set of examples that we have here. So based on this idea that the equation has to have x and y to the first power, we want to identify which of these are linear equations. So you may want to pause the video, go through these on your own, and then check to see what results you get. But I'll go ahead and continue and go through all of them for you. So in this first example, y equals 5x plus 12, that is definitely a linear function. It is written in slope-intercept form, that y equals mx plus b format. The one right next to it violates that rule about the exponents being to the first power on both the x and y. So this one is not a linear function. If you recall, anything with an x squared in it is going to be a parabola, that U-shaped graph. The third one, as we move across, is another linear function. Both variables are on the same side of the equation, 3x plus y, so that one is written in that general form, that first one that we see over here. Y equals 1 over x plus 2. So because that x is in the denominator, so even though you might say, wait, the exponent is 1, if we recall our exponent rules, 1 over x is really x to the negative first. If you don't remember that, we'll talk about that later when we're studying exponential functions. But that makes it so that this one is not a linear function. The next one, y equals 3.8. This one actually is a linear function, even though the x is missing. The result of that graph would just be a horizontal line through y equals 3.8. So it would still be a straight line, it would still be linear. The next one with the square root of x in there definitely is not a linear function. The second to last one, x over 3, so the x is in the numerator, so the exponent on that one is still 1. And we could rewrite this as y equals 1/3 x plus 2. That's x there. So that would fit into that slope-intercept form, which we know is a linear function. And then the last one is written in that point-slope format. So y minus 1, kind of the left-hand side of the equation, equals 6, which is the slope, times x. Now, even though it's plus 3, it still fits into that point-slope form. So this one is a yes, as was this one here. Moving on to the next slide, as we look at the graphs in front of us, again, what it means for a function to be linear is it just means it needs to be a straight line that passes the vertical line test. We are talking not just about straight lines, but linear functions. And so clearly the first one is a yes, whereas the second one, that U-shaped parabola that I mentioned a moment ago, is a no. What may be confusing is this first one at the bottom row. Because that one is vertical, even though it is linear, it is not a function because it fails the vertical line test. We have multiple points along its length that are all stacked on top of each other, so it fails that vertical line test. Whereas that other equation, by the way, on the other slide was y equals 3.8 and resulted in a horizontal line. This one here, the equation would be x equals 1. So when it's x equals a number, it actually does not end up being a linear function. It's a straight line, but because it's vertical, it fails that definition of being a function. But the last one here is a function, horizontal line, passes the vertical line test, it's a straight line. So here we have a yes. We can also be presented with a table of values and asked to determine whether that table represents a function or not. And the way we determine that is whether or not both the x column and the y column have a consistent or a constant rate of change. And so the idea there is we have to be adding or subtracting the same thing every single time to get to the next number in the table. If we see that pattern in both the x column and the y column, then we are looking at a table that represents a function. So for example here, to get from 3 to 6, we've added 3. To get from 6 to 9, we've added 3. To get from 9, to 12, we've added 3. So we have a consistent pattern of adding the same number over and over again in the x column. Now, if we look at the y column, it doesn't have to be the same as what we see in the x column. It just has to be consistent within its own column. So from 18 to 24, we're going up 6. From 24 to 30, we're going up 6. From 30 to 36, we're going up 6. And so we have a consistent pattern in each, so this one is a linear function. For the second example, we can see that we're going up by 1 every single time in the x column. 1 plus 1 is 2, plus 1 is 3, plus 1 is 4. In the y column, we're going up 3, but then we're going up 4, and then we're going up 5. Now, there's a pattern there for sure. We could predict what that next pair of numbers would be. We can almost certainly say that it's going to be 5, and then we would add 6 this next time to get to 20. But even though there's a pattern, it is not a linear pattern because in this y column, we're not adding the same thing every single time. So this one is a no. For the last one of the set, if we look at that one, so 8 down to 7, we're subtracting 1. 7 down to 6, we're subtracting 1. 6 down to 5, we're subtracting 1. So even though it's a subtraction-based pattern, it still holds. We have to be adding or subtracting the same number over and over again. And if we look over here, we're going up by a decimal amount, but hopefully we can see that's up by 0.5. Here we're up by 0.5. Do that one more time. So we do have consistent addition or subtraction-based patterns in both the x and y columns. So this one also is a linear function.